So welcome to our 2022 Air Seeder Clinic. We have a few presenters here this morning that we will have for today's session. So we'll just do a little bit of introductions here. So first off, myself, Matthew Kynock. I'm one of our solution support specialists out of our dealership in Melita. Then we've got Connor Rex, one of our solution support specialists out of Oak Bluff. Matt and Connor and I will be presenting here this morning. And then we've got Blair Steen, our solution support specialist out of Neepawa. Blair will be here in the background. So if you guys have questions, for simplicity, you guys, your mics are muted right now, but please ask your questions in the chat pod. At any point throughout the presentation today, Blair will be trying to answer questions as well as Connor and myself. And then certainly last but not least, we have Emilio Perez. Emilio is our production system specialist with John Deere, and he'll kind of be our last presenter of the day going over some of the topics. So with it being a virtual clinic, it's going to be a little bit different than obviously an in-person one. We won't be able to cover everything on every drill, and we obviously don't have a physical piece of equipment to do a walk around. So kind of our agenda here for this morning, what we're going to look like is we're going to start with myself. It's going to be doing kind of a cart overview with a little bit of a walk around, going through some physical setup things on the cart, talking about rollers, and I'm going to talk about our RelativeFlow blockage. Then Connor's going to go through our simulator, going through our cart setup, calibrations, our maintenance modes, some of our tool setup as well. And then Emilio is going to kind of finish up with some changes to the models and then talk about the changes to our TruSet seating for either things like our packing pressure or our depth control for some of our drills. So, like I mentioned, at any point, we highly encourage questions and things like that in the chat. So with that, we might as well get going. So where I'm going to start off today talking about the cart is I'm going to talk everything to do with air. So we're going to talk about things like our tires, our hose routing on our carts, fans and speeds, and a lot of things to do with those. A common question is why we have flexible hose on the mini hopper, and a lot to do with things like tank pressurization. So the carts we're going to cover today is going to be our hydraulic drive carts. We're not going to really be going over anything that's specific to the ground drive components on some of the older carts. We will be trying to cover as much as possible the new C-Series carts, as well as the dual fan 1910s and the single fan 1910s, but there are differences obviously between all three of them. So we're going to try and cover all the bases for all three different types of them. But if we don't cover something, obviously, and you guys have a question, by all means, type away in the chat pod. So one of the first things first I'm going to talk about is simply tires. So proper tire inflation is going to be key on any of our carts. The tire pressures could be referenced in your operator's manual. So with that, we're trying to maximize our flotation and minimize our compaction. It's looking like this spring is going to be significantly wetter than some of the ones that we've had here in the last few years. So maximizing that flotation is going to be key. So with that, when we actually set our tire pressures, we generally want to do that with the tanks half full. And part of that ties into that our proper tire inflation is very important for our wheel speed calibration, which Connor will go over later. And that's going to be very, very important for our cart speed and for our rates. So if our tires are severely deflated and our cart speed isn't matching up, we're going to have issues with proper application. So tire pressure is very, very important. Okay. One thing that obviously is a little different with our newer series of carts, we do have SFT or IF tires, so we can run lower pressures to have more footprint on the ground to minimize our compaction. So then our hose routing, so there is some differences between, this is more referring to the C series than our 1910s, but there was a big change between these carts, specifically in regards to our hitch on them. So we kind of just had the casters on the front of our 1910 and a single pivot. Now we have a wagon steering hitch on our C-Series carts, and part of that is designed so that it will help the cart follow behind the tool. Especially with bigger tools and in side hills, the bigger weight and the larger size of those carts won't drift as much. But with that, there's a couple changes with our hoses. We need to have a little bit of sag in our hoses on the hitch on the C-Series carts. If they don't, they'll be too tight. They could damage and pinch the hose. They can be rubbed through much more quickly, or they can actually pop loose while turning if they're extremely too short. However, if they're too long, they can hold seed and have a bit of a pool, especially with smaller volumes or rates or seed sizes with things like, say, canola. So this is there, I mentioned, different from the 1910s. But it's something to keep in mind, as a bit of sag in those hoses is normal. Don't try and snug that up on those carts. Otherwise, we'll have issues with those things popping off. Okay, so with that, I'll carry into here a little bit of things with our fans and our conveyor. So we have a valve block on the carts to swap our hydraulic flow to control our conveyor or auger. I have conveyor type simply because that's the only option for the C-Series carts. There is no auger option for those. So location is different from the C850s to the C650s, as well as it can vary slightly whether it is a toe between or a toe behind for a C650. There is a different valve on the 1910s as well. It hasn't really moved or changed in years on the 1910s. There's a diverter valve up in here, usually under the frame rail by the front tank, where we see it inside the console or the panel here on the right side picture next to our remotes for our wireless conveyance on the C-Series carts. So same principle, you're basically going to push in or pull out and twist to divert the hydraulic flow from one mode to another, whether it's the fan or the conveyor. So hopefully you guys can see that and it's not too small on your screen. So we're talking about fans here a little bit for the 1910s. So we have two options with those. We have a single fan, and with that we're going to use a diverter in our plenum to split our flow between double chute tanks. If we have a single chute tool, we will not have that diverter in the plenum. Our tank pressure is a result of our fan speed in this circumstance. So that the faster we have our fan spinning, the higher our tank pressure is going to be in those single fan 1910s. When we look at our dual fan carts, obviously they're a little bit different because we have two fans, so we can control our top and bottom airflow individually by controlling our hydraulic flow for each fan. One thing that makes the dual fan carts different on the 1910s is we have manual valves to adjust our tank pressure, and I'll show you a little bit of a picture of that here in a couple slides. It's basically the same as the C-Series, but I really wanted to point out just some of the differences. These are the fan speed recommendations here for a single fan cart, so that we can see that we're getting to our extremely high rates. You know, that fan's going to be that 4,200, 4,700 RPM. I believe what 5,000 is almost max on these carts in a perfect world. Whereas our smallest fan or lower fan RPMs on these single fan carts is like 2,500 to 3,500 RPM. Okay, so the reason that becomes a little bit different now is when we switch to our C-Series carts. So again, standard dual fans, there is no single fan option for these carts. Again, we're going to use our hydraulic flow to set the RPM for our top and our bottom chute. We can do 300 pounds of fertilizer through the top chute. We can do 250 pounds of seed and fertilizer per acre through the bottom chute. So one thing that's actually slightly different is there's actually slightly more capacity out of the top fan that feeds the top chute than there is out of the left fan that feeds the bottom chute. So it's something that's just a little bit different. Now, the big thing that's different on the bottom is because we're running a much bigger fan that really moves a much higher volume of air than our single fans. We can see below in our RPMs for our fans down here, we can see that for rates like our canola, we're only going to set it as low as 1,100 to 1,600. We're not going to have it at that 2,500 or 3,000 like we would on the single fans. So we run these fans significantly slower in RPMs. If we look down here at our heavy fertilizer rates, we can see that even for our 200 to 350 pounds an acre rates, we're still running that fan about 2,700 to 3,100 RPM. Now, the 3,100 RPM isn't max. 3,500 RPM is the maximum speed on these fans, but you do need to have a 3/4 inch coupler for the fan to be able to get that full fan RPM. If you're only running a 1/2 inch coupler, you're going to max out at about 3,000 RPM with it. Okay. One other reference too that we've ran into is, say you were doing just canola through your bottom chute, or some really small rates, things like that. God forbid some reseeding canola. So if you weren't even putting any fertilizer down, you don't want to still go lower than the 1,100 RPM for the canola, for the simple reason that there's not enough product in the lines to make back pressure. So we need a higher fan RPM to still get the product down the lines. Otherwise, we can end up plugging the drill. Okay, one of our product specialists can relate that from experience. So Not saying any names. Anyways, so yeah, that's one thing to keep in mind is, yeah, don't get too low if you're in the really, really low rates or just say seeding straight canola. So, oh, I guess I forgot to add the pictures for this slide, so that was my bad. So, though I was going to add a picture here for the lamps. So there's a little bit difference. There's lamps on the front of your 1910 cart, and those are used to indicate your fan RPM. So when you're adjusting your hydraulic flow in the cab, if you have your fan set to say 3000 RPM, as you increase the flow on your hydraulic, if your fan is too low, the bottom lamp will be on. If your fan RPM is too high, the top lamp will be on. And when you're within range, both lamps will light up when you're adjusting your fan RPM. That doesn't exist on the C-Series carts. There is a lamp, but it is used for something else entirely. So, yep. Great slide there. Good job, Matt. Okay, so tank pressurization. So this is where we start to see things are a little bit different between the carts. So we have some pictures here of old and new, and then on the bottom left we have a picture of our manual valves for our C-Series cart. So what the manual valves let us do is we can manually throttle the airflow from our tubes to our tank, and we can control that whether it's top or bottom chute. So a part of this system then is we actually have a pressure sensor for each of our tanks. And that's what we're seeing there in the bottom right under our new is that the pressure sensor is going to give feedback to our side display on our cart. And that will give us a much better idea as to what our actual pressurization level is set to. We can also read that inside the cab as well on the display. And then for the older carts, our 1910s, that's what you're going to see up there with those manual gauges under where it says old. You're going to see generally 2 or 3 of those, and you're going to want to run those guys in the green. Those are obviously going to be indicators to see if we have air leaks, if we forgot to close the lid on a tank, things like that. And we need that proper tank pressurization to make sure that we're going to be able to put on the correct rate with the tank. If we overpressurize our tank, that can result in potentially some seed blow by, or we can over apply with our rate. And if we don't have enough tank pressurization, say in the case of oats, that could potentially encourage some bridging because we don't have enough pressure to help the product feed. So those are kind of the 2 different systems there. So how the system works on these guys, it's pretty straightforward. We're just going to turn the handle on that tank to adjust the pressure for each tank. So right now, all those handles are facing up. So that means all of those tanks would theoretically be set to the bottom chute, and we would have full tank pressurization. So if we wanted to restrict it, we would start turning those handles counterclockwise, more towards the middle to decrease our tank pressurization. If the tank was set to the top chute, the handle would be facing the other direction. And as we go clockwise then, from all the way at the top, it would then limit our tank pressurization if the tank was set to the top chute. So it's kind of easy to set, which is nice. You can view it right on the side display as you're adjusting the handle. It will adjust the pressure on there. So it is kind of a nice confirmation. And then I realized some of my pictures here for the side display are hard to take with a phone. But there's an example there on the left-hand side. We can see that tank pressurization level at the top left of our run page. And then we can see an example on our side display on our cart. There we can see that we're running in our red, our green, our yellow, or our white coloration. So generally speaking, we're always going to want to run the cart in the green. The yellow is meant to indicate for our lower rates. So if we have a tank that's going to be running at rates lower than 50 pounds to the acre, that's where we want to make sure that we're running in the yellow. If we want to run in the white, that's generally in our higher rates. So those are some things we do have a little bit of adjustment in. Okay. So now let's talk about those pressure sensors here for a second. So I got a couple pictures here of some of the major areas of our tank pressure sensors on our C-Series carts. So starting at the left-hand side, we can see our return to the meter. So that's going to come back into the meter housing just like it did on the 1910s, even with the manual gauges. That's going to put that air pressure back into the meter housing. Our center picture there is our pressure sensor itself. So this is going to be mounted above our hydraulic motors and things like our agitation setting and adjustment on the right-hand side of the cart. And it's going to be there for all of them. So there's a pressure sensor mounted there. And the other one that I actually feel is also kind of important is our tank inlet. So this is where the air is going to flow from the tank into the small lines to go to the pressure sensor. And if you open the lid on each one of those tanks on a C-Series cart, there's going to be that little barbed end up there at the front side of the tank. And that's where you'll find it. So with that, what can happen is hoses can get plugged if the tank is filled exactly all the way to the top if you pack it full. You can get fertilizer and product down through that barbed end of that tank inlet, and that will then plug your line, and you're going to very quickly be getting tank pressure alerts inside the cab on the display. So they're relatively simple to clean out. You just need to blow some pressurized air through the lines. However, it is really important that we do not blow pressurized air through the pressure sensors. It will wreck the sensor. So with that, we can pop the hoses off on the sensor side, and then we can blow air either way at the pressure sensor. Okay. With that, these lines should be checked and cleaned periodically. They do recommend to pop the line off where it returns to the meter, and you can stick a piece of wire in there to make sure there's not any kind of dust or fertilizer buildup, things like that in there. And then it's also easy to do from the tank inlet side as well. So another big part then is our tank lids themselves. So one big thing on the C-Series carts is they don't actually need to be slammed shut, contrary to how we see most of them being done at farm shows. The few tricks that I've kind of found using them is once they're shut, a handy thing is to pull the handle towards you to make sure it's sealed. If you don't pull the lid in nice and square so it runs on the tracks, you could potentially have it come in too high on the lid farthest away from you, and it won't actually seal properly. So if you pull the handle towards you, it can tip the lid if it's not secured. It is operated by that foot latch, so there's one of those for each of those tanks. Like I mentioned, that we should have that lid slide on those tracks. Now, up at the top right, we can see our lid for our 1910s, and that hasn't changed in ever, really, for the most part. It's the same adjustment. We've got that tie rod adjustment there that we can do for our tensioning on it, and we do have the adjustment end then on this side. Same principle. We want to make sure they're nice and tight and snug. We don't want to make sure there's material built up on the seals. We want to make sure the seals are in good shape on those 1910 lids. They are a rubber seal, so they are quite durable. Now, one thing that's different on the C-Series, though, is they don't run a rubber seal for the tank lid to the tank. They're a foam seal. So this is one of those things that we recommend the guys should probably keep on hand, is maybe a spare set of seals for that, for those tanks. And as a backup to those seals would be some 3M spray glue, like in a can. So if the foam strip starts to come off or something like that, you could quickly glue it back down as a backup. We do expect that these foam seals will need to be replaced quite a bit more frequently than the rubber seals on the 1910s. So just a little different, the way the lids seal and things like that. It's a little harder to have a rubber seal in there. So, okay. Last but not least with our air is our secondary manifolds. So we should make sure that we don't have leaks and our hoses are tight on our manifolds. And we should be making sure that we're checking our dome lid for wear. So by that, I'm looking at a new style of our manifolds here, but we have our lid side here where we've got our rubber top. We should make sure that there's not holes worn inside this guy. If not, we should replace the lid. One aftermarket option that we can do as well is we can get a stainless cap to go on those guys as well. One thing to keep in mind though, the stainless steel cap and really high fan speeds could maybe be a little bit worse for some pulses or things like that, maybe for breaking some seed than the rubber one. So just something to keep in mind, but we have seen a lot of customers add those stainless covers to those lids. So, okay, the mini hopper. So I mentioned the flexible line on the mini hopper. So a lot of guys, if they've seen a C850, I've had this question quite a few times, we have 3-inch stainless steel primaries running from our rear tank to our middle tank to our front tank, but then we have here flexible line running to the mini hopper. And the reason that we do that is simply because it allows the load cells to be more accurate. The stainless steel lines will actually hold up the mini tank slightly. It can affect the readings on the scale, and obviously we want that scale to be as accurate as possible when we're dealing with those lower rate, smaller materials like our canola or alfalfa seed, inoculant, things like that. So a couple more things just with the mini hopper that's kind of nice. So it does have a 50 bushel capacity. There's a bag cutter built in as a part of the screen. So we can see a picture there of a bag of canola. You can drop it onto those spikes and that will rupture the bag, and then you can pick it up and the canola will pour in, which is nice. It is waist level, which is handy, so it makes it a little bit easier to put the canola in there. And the mini hopper does have the flexibility that could be filled with a conveyor or with bags. So you could fill it from waist level with bags, or there is the ability to swing the conveyor over and fill that mini hopper from the top with the conveyor. So then I've mentioned a couple times so far our C-Series cart display. So these, I've got a couple pictures of what the run pages might look like, or some of the things that we can do with that cart display. So the first one is our tank weights. So that's our picture up there in the top right. So we can go through each tank and we can actually read how many pounds are going into the tank. There is the bar there on the left-hand side that will fill up, and that's because of the sensor that's inside the tank that will reflect as the tank fills. So it's kind of handy. You can see your weights and things like that as you're filling the cart. So if you have a rough idea as to how many pounds you need to finish the field, it can make things a little bit more accurate. The second one then is our tank pressures. So that's what we can see down there in the bottom right. Again, not a great picture, but we can actually see for all 4 tanks, we can see those pressurization levels for all of them. And then in the bottom left, we can see our meter calibration. So this is one of the big changes that's really nice. I personally like on the C-Series is that we can calibrate the cart entirely from the side of the cart. We don't have to run from the cart back to the cab and input things like our weights when we're meting our product out for our product calibrations. Connor's going to go through the calibrations a little bit later. Through the simulator portion of things, but this gives you the ability to do each tank individually, or you can do all of them at the same time. The cart does come with 4 bags to hang underneath there, so you can do all of them. It does have the scale. All those are part of it that comes with the cart. The one thing that you can't do from the side of the cart is a meter verification. So we can calibrate the cart from the side, but we can't verify a stationary rate or a moving rate verification. That has to still be done from the display inside the cab. So, okay. Any questions coming in there, guys? Yeah, well, sorry, Connor's bringing up a good point. If you start a calibration on the cart display, you have to finish it at the cart display. You can't do there and the display inside the tractor at the same time. It's one or the other. So. Okay, so with that, then we're going to switch things up here a little bit, and we're going to spend a few minutes talking about rollers and our meters. So for those of you that have had John Deere carts for a while, not a lot of changes here. We still have our yellow roller for our lower rates. We have a black roller for our 20 to 130 pounds, so our small seeds and into our lower rates of fertilizers. We have our green roller here for small seeds, some pulses. Now we're starting to get a little higher fertilizer rates. Then we have our blue as our highest rate roller, that 40 to 265. So this is going to be things like our granular nitrogen. We're going to see things like oats, potentially barley through this guy. Pulses could be peas and beans, things like that through our blue roller. Then orange is our newest one, but it's not really new at this point, but that's a 35 to 240 pounds an acre. But this orange roller really has a specific purpose, and it's really meant for large seed size with section control. So if we have seeds that are bigger than 6 millimeters, that's when we would use the orange roller, but again, only on a section controlled cart. So the flutes on that roller segment are almost identical to the blue, except they're shorter. So what happens is, as the roller's turning with our gate shut with section control, it prevents binding and damaging of seed inside the meter housing itself, or the meter roller itself, so that we're not damaging a bunch of seed and aiding or hurting the meter segment. So that's why we have it. So we do not want to use that orange roller for things like fertilizer or on a non-section controlled cart, because we can actually have the product almost essentially roll past the roller down into the airstream. So. Okay, so with that, then we can see the pictures of the 5 colors of our rollers there. We can see the some of them have tuning rings installed on them. So we can see the black, green, the blue, and the orange all have one tuning ring installed on them. So generally speaking, when we install our tuning rings, we want to install them so they're relative to each other. So it kind of shows down there in the bottom left, if we had a 12-run manifold and we had no misses on it, or it was all full with hoses feeding our openers, we would have no tuning rings on it. If we had in a circumstance then where we had one gap left open on our secondary manifold, that's when we would put a tuning ring on to restrict the flow to that one so it matches the other manifolds. So the tuning rings are really all about balancing the seeding rate across the tool to try and make that our COV as evenly as possible. Now, there are some exceptions to that. So if you guys look at that top right picture, you can see that canola roller is pretty much jam-packed right full of tuning rings, and we do that for a couple reasons. One is it's to speed up the roller, so it's not running as slowly as it could. This was a really big deal back with the ground drive carts. You could start to get a little bit of pulsing in the transmissions when you were really, really low on your speed setting. Not as big a concern in the hydraulics, but it also fills up space with our seed pool in there, so we do get a little bit less of a dumping effect with our section control when those gates open and close as we come out of our headlands. Okay. One other thing too that I should point out is that generally speaking with a section control cart, especially as we get into our bigger roller sizes like our green and our blue and our orange, we don't want to install our tuning ring right in the middle of the meter segment. We want it spaced slightly off to the side one way or the other. The reason for that is in behind where the gate is, and I don't have a good picture to show you guys this, unfortunately. There's a lip in there, and it gives an area where we can get material building up and sticking with the brushes and jamming. And you can actually, if it's really bad, it will actually wear grooves into your tuning rings. The other thing that we don't want to do with our tuning rings with a section control cart is we don't want to put the tuning rings all the way to the outside of the meter segment itself. There are lips in the gate that actually taper in, and if we put the ring all the way to the outside, it doesn't allow the gate to actually close all the way. So then we'll get gate detection warnings, things like that, because the gate physically can't get snapped shut or closed shut by the hydraulic side of the system. So, okay. So hopefully that goes over a little bit. I don't know if there's any questions coming in on the rollers there from anybody. Quiet crowd today. Okay. Okay, so the other thing that I should mention too is that through our partnership with ANI, we actually do have a few other options in rollers. We've had a few dealerships sell some of these, but admittingly, lots of our dealerships have not yet. So I will say that most of our product specialist team has not really spent time or ran these meter rollers, but they're a little bit different because they're spiraled now instead of a straight flute in those rollers, and the idea is to help give a little bit more consistent delivery of seed. The other thing that's a little bit different is they actually have introduced now a white roller, which we can't quite technically get through Deere yet, but it's a half rate of the yellow roller. So it's actually a 1 to 10 pound to the acre roller. So there are tuning rings available for these rollers, so it is an option if it was something you guys thought you wanted to try. It's something they're easily swapped into your current existing meter housings. So the rates for the yellow to the orange up there at the top, they match exactly with what we have out of our OEM rollers for rates. So yeah, it's definitely something if you thought you wanted to try, or if you had worn roller segments or tuning rings, it might be something you might want to look at or consider. Okay, so let's talk a little bit more about rollers and some of our maintenance. So our rollers should be taken apart and cleaned each year. The argument could be made that they could be taken apart and cleaned every time you change products, even with them in some circumstance, especially say your blue roller and high rates of fertilizer. So when we do that, we want to make sure that we're checking our bearings inside the roller. We want to make sure that we are replacing our tuning rings and roller segments when they have wear. We don't want those things worn out or the flutes damaged. We don't want our tuning rings worn with grooves in them, things like that. In the back side of the meter, we do have brushes in there, so we want to make sure that the brushes are replaced when there's grooves worn in them. Typically, you might have grooves worn in them when there's seeds getting jammed or stuck against the tuning rings. We also want to make sure there's no binding in the roller, so we want to make sure that it's not overly tight or imbalanced or warped with it. So another big part is with our section control carts is our part number 19 here. This guy here is our gate detection sensor rod. So that's going to slide into the meter housing, and that's what's going to have that electrical connector sticking out of it. So that's what's going to detect the presence of the magnets inside the meter segment to know whether or not the gate is open or closed. Okay, so that sensor rod should be kept clean as well. With that, we want to make sure our gate area is clean, and I'll talk about that here in the next slide a little bit more. And we want to make sure our seals are in good shape. So we do have a foam strip on the back side of our meter housing when it goes in, and that's to prevent dust and buildup from going around the back side of the roller where the pins from our hydraulic valve block push the gates open and closed for our section command. Okay. And then last but not least with our rollers, they should be stored standing up. We do not want to store them laying on their side. They can warp over time when laid on their side. Okay. So that was a kind of a little bit of, we'll say, preseason maintenance. Now let's look at a little bit more at some daily maintenance. So rollers actually should be removed daily to inspect and clean if necessary. This is especially true with our high rates of liquid fertilizer. I would recommend it when we're doing soybeans or pulses to make sure that we're not getting buildup of material in and around our gates, and to make sure that our brushes are staying in good shape with those large seeds. As well as then things like oats with lots of dust and things like that. We want to make sure that our meter segments aren't plugged up. Okay, so down there in the bottom left is the picture. This is what I'm referring to, is to make sure there's no buildup behind the gates in the roller. So this is kind of looking at the roller from where the bottom, where product would come out. We can see our gate is pulled up in this circumstance here. And then there is a little spot right here. I'll just cover it with the laser pointer right there. That is where our magnet sits. So if we have material buildup in there, that magnet isn't allowed to seat all the way back down. And this is where we can get a lot of gate detection errors with the air card as well. So we want to make sure that we're staying nice and clean in those areas for the section control to work properly. Okay. All right. Any questions on rollers at all from the, nothing? Jeez. All right, so let's talk about agitation here a little bit then. So I popped the cover off this this hydraulic drive cart. So this is maybe a chance to talk about a few components here. So we do have our hydraulic valve block here, and we have our hydraulic motor in behind, and then we have our drive sprocket and our encoder to measure our shaft speed for the drive of the system. We have our idler sprocket here, and then down here we run our drive to our meter housing, and then we run our arm up here to our agitation shaft. Okay, so our agitation, just like we had on our older 1910s and all the way back to the ground drive carts as well, is all we're going to do is undo this bolt and move it on the sprocket, and that's going to allow us to adjust our speed from high speed to low speed. Okay, the further it out is on the sprocket, that's high speed. So when are we going to use high speed with our agitation? That's where we're going to use it for products that are more likely to bridge, or products that are dusty. So maybe some things like barley, oats, are circumstances where we would switch that guy to run on high speed. A couple years back, we did come up with a newer, longer agitator. So on that shaft that runs in here at the top of the meter housing, we do see our agitators here that mount to that shaft. They are longer. There's ones we can get. So that's the part number for those guys. And they are compatible with our C series and our 1910 carts. Okay. Now that necessarily won't be the end all and no all answer to, bridging issues with oats. Sometimes the oats will bridge above that. Sometimes they can even bridge in the roller itself. One of the reasons why, generally speaking, we're going to recommend that blue roller over a green roller for oats. Okay. Now, just because I got the cover off and we're here on the slide, there are two 50-hour grease zerks for each tank on this side when you pop that cover off. So one is going to be in behind this sprocket here for our meter, and then the other one is going to be up here for our agitation shaft. Those guys should be done every 50 hours, and they take one shot of grease per on that interval. So not terribly often. Okay. Now, continuing talking about our meter housing. So we're going to want to make sure that we're inspecting the seals. Inside, when we pull our rollers out, we're going to have our foam inserts in there inside those plastic housings. We're going to remove those guys out of there as well. Make sure that they're in good shape. Make sure that the foam's in good shape. In the spring, you're going to want to run your fan to make sure that we're not leaking air. So we want to make sure that we're not leaking air out of any of our primary pipes. We want to make sure that all of our seals in our meter housing are good. If we're leaking air, we're going to be affecting the performance of the drill. Check our section control valve block on each tank for leaks, which I realize I don't really have a great picture of that, other than it would be in back behind here, would be the section control valve block on each of our tanks. So make sure there's no leaks in there as well. One of the things that we can do is with the section control, we can cycle the sections manually, so it's not a bad idea to make sure that those guys are working and not stuck. Connor will show you guys in the simulator where we can do that. The other thing to keep in mind too is don't leave your meter housings partially in or out with a section control cart. Whenever you fire the cart up, it's gonna stroke the plungers that control the gates, and they can damage your meter roller if it's left partially in or turned. So the best practice, generally speaking, for keep putting the rollers inside the meter housings with section control is either have them all the way in and latched or all the way out, nothing in between. Okay. Now, top and bottom chute. So this is really the same as the 1910 and the Sear series in principle and the way you operate it, but there is a couple things different, and it really has to do with what could be called the bottom plate. So our bottom plate would normally drop right out on the bottom of our 1910s. You undo those latches and you drop the plate right out. So if you were doing calibrations or you needed to empty the tank, the product could flow right through the chute divider and into your calibration bag. On a C-series card, it actually swings down out of the way. So we actually undo this pin here, and then we can pull this handle down, and it will unlatch and swing down out of the way. Operation-wise for it, then once the handle is down or our slide mechanism here, we just lift up our pin here and it goes all the way in to allow product to flow down to our bottom chute. We pull it all the way out for product to stay in the top chute. That hasn't changed. It should be cycled daily. That's been the recommendation for years on these guys, is to cycle that to make sure it doesn't get stuck. If you've ever had one get stuck, not a pile of fun to try and unseize. Especially on your fertilizer tanks. Okay. One of the next ones then as a part of our meter housing is our half-width disconnects. So they should be cycled daily on 1910s, and the argument could be made they should be done on the C-series carts as well. Otherwise, what happens over time, they can bind or they can seize. They won't fully open or close. They'll kind of twist their plastic up there in the top, and they won't fully open or close. So we see our two handles on our 1910s. We've got one for the left and one for the right. So that's why we call them a half-width disconnect. Gives us the ability on our non-section control carts to shut off flow to either one half of the drill. If they're all the way down, I believe that's open. And if you push them all the way up, that should close the half-width disconnect. Now, it's a little bit different on the C-series. We actually open and close them with electric actuators. So if we see here on our picture here, we can see the rod side of that electric actuator tying to our handles for our, well, I'll say full width disconnect now, because the reason is you either open and close all of it or it's either open or closed. You can't do half of the tank with it. One of the reasons why is that all of our C-series carts come standard with section control. So even if you didn't have the automatic section control, you could still manually go into the display and turn sections on and off. So you don't need to have the ability to control half the tank like that. Now, how we control that actuator is each of the tanks is going to have a switch that's going to look like this on the cart. So they'll be in different places depending on whether it's a 650 or 850 or if it's a toe between or toe behind. But really the big takeaway is don't try and open and close the disconnects on more than one tank at a time. That will blow the 30 amp fuse that supplies power to our 9-pin connector on our tractor, and then you'll be going back to your 4-wheel drive and taking the back cover off the cab to get in there to that 30 amp fuse. So yeah, just do one tank at a time. So I mentioned bin level sensors before. So I don't really have a slide here for the 1910s. However, on our C-series carts, we actually run an ultrasonic bin level sensor now. So there's one of those at the top of each one of our tanks, reads down all the way to the bottom. So one of the nice parts is it actually fills the bar gradually now or drops as you're emptying the tank, which makes it a little more representative of what's actually in the tank. The sensors on our 1910s, there'd be, what, 3 of them in there? One at the bottom, one halfway up the ladder, and then one at the top. And all they would do is they would fill the bar in 3 chunks when product was basically tripping the sensor. So this just makes it a little more accurate, a little more consistent, down to 1 sensor instead of 3, which is nice. So One thing I should point out is these sensors are up in the tank, and if you follow that wiring harnessing, there'll also be plugs in each of the tanks to mount cameras as well. I forgot to add a slide for that one, but each of those tanks comes camera ready to hook a camera to it. So, okay. Yes, yeah, the Mini has 2 positions, yeah. Up top or down lower if you're filling from the side. Okay. The load cells, so I kind of showed this screen already a little bit, so we can read the weights from either the cart display or the cab display. We can actually read the weight inside the tank. One thing to keep in mind is that wind can affect the readings of those guys as well. When we've had some really, really windy days and those tanks start to get a little more to the empty side, that can put a lot of leverage and push on that tank, and that will affect how that scale reads. They can be zeroed from the cab display. Connor will show you guys where to do that in the simulator. One thing to keep in mind is that each of the load cells on the cart is unique. So we have, I believe it's 4 or 6 load cells per tank, depending upon which of the C-Series carts you have, and each of those load cells is unique. So you can't take a load cell from the rear tank and put it on the front tank. Even the location is specific, and they're programmed that way, so there's no extra calibration steps if we have issues with a load cell. This is what allows us to run ActiveCal. I won't go into ActiveCal a lot. That Connor's going to go through that in the display, but that's how we can do a active calibration while we're seating on the go, is because we have the ability with those scales. Okay, let's talk about conveyors. Now, I'm specifically more or less going to talk about the ones on the C-Series carts here with the conveyors. But we have a 12-inch tube and a 12-inch tube, and inside that 12-inch tube, we have a 19-inch belt. So one of the things we don't want to make sure is we don't want to over tension the belts on the new machines. So the tensioning is done on the conveyor end the hopper end of the conveyor. There'll be 2 threaded rods where we can adjust the tension on that. That's also the same place that we're going to control our tracking adjustment is done in the same spot on the hopper end for it. It is much faster in terms of moving product than our 1910 conveyors or augers. We can actually theoretically hit up to 100 bushels a minute max with the conveyor. I haven't quite seen us hit that fast, but it is quite a bit quicker. But because it hits that speeds, because the tube's so much bigger, but it actually does it with a slower belt speed, which can hopefully help us be a little more gentle on product as we're filling the tank as well. So one thing that is a little bit different than our older conveyors is we do have 2 little red on-off switches or push buttons. So we have one here down here at the hopper end, and then one right up here at the top, as if you were at the top of the cart while you were filling. And they are a kill switch. So if you push those switches in, it's going to immediately stop the conveyor. You have to pull them back out to allow the conveyor to run again. So if you're all of a sudden in a situation where you're going to overfill and things like that, you can push that guy in and it'll immediately kill the conveyor. However, it's important to remember to pop it back out. Otherwise, it could be exceedingly confusing as to why the next time the conveyor won't turn on. So with that, the conveyor does have 2 speeds for movement. So it was designed specifically to have 2 hydraulic speeds for movement, whether you're an inexperienced, a little more inexperienced with using the hydraulic conveyance side of it, or whether you're more experienced and allows you to move that whole conveyor assembly quite a bit faster. Okay. So with that, there's a few things that makes the conveyor a little bit different. So the remote is almost the same as the 1910s, but there's an extra lift step with the C-Series carts. But some of the abilities to control on the remotes is our hydraulic latch pin. So that's exclusive to the C-Series. So at the top front where the conveyor locks in, there'll be a hydraulic pin. Hold it in, so you're going to hit that to retract the pin to allow you to move the conveyor. That pin will time out over time, so it will generally slide out while you're filling. So you'll have to remember to bring the pin back in before you can latch the conveyor back down into the cart. There are 2 arms to move it in and out, but we also have a up and down with a parallel link on the conveyor arm, and then there's also the tilt up and down like we traditionally had. We have the ability to control our conveyor belt speed from the remote, our belt on and off, and then like I mentioned on the last slide, our hydraulic speed. So that's the ability to control the speed of that conveyor being moved. So we do have 1 wired and 1 wireless remote that comes with that option. You do need to turn it on with the control box over here with the green button to allow to use the remotes. So one thing to keep in mind that's a little bit different is on our older carts, the conveyor, hydraulic conveyor being or auger being moved, as well as the actual movement of the belt on the 1910s was done purely off of our fan circuit. It's a little bit different on the C850, so we actually use the power beyond for movement. So that way we have more control. So if our fan was set really, really high, our conveyor arm doesn't necessarily move at top speed. But if our fan was low, say for canola, that means that our movement of the conveyor isn't going to be really slow. So we run power beyond for the movement of the conveyor, but we still have to have that top fan engaged, and that's what's going to allow us to move our conveyor belt. So that's still very similar to what it was on our older carts. Okay. No, power beyond will just be for movement of the conveyor, not the belt. Yeah, belt is only from the top fan. Movement of the conveyor is from power beyond. So it's a little bit different that way than the 1910s. Okay. Any questions yet? Not a one. Okay. Yep. Perfect. That would be a no. Yeah, unfortunately. Yeah. Yeah, sir. Okay. Yeah, no, unfortunately, there is no retrofit kit for the ultrasonic sensors on the carts. So, okay. All right. So with that, I'm going to go over blockage here a little bit real quick. And then once I'm done, then we'll actually take about a 5-minute break. We'll been going for about an hour. You guys will be able to stretch your legs, grab a drink, go to the bathroom, and then Connor will be getting ready to go over the simulator stuff. So, the reason I'm going to go through relative flow blockage like this is because it's easier to show it in the simulator. It doesn't really show the blockage being used. So here we see a full page example of our relative flow blockage. So we can see that it's running for each of our top and our bottom chute, as well as we can see below that from our 1 to our 10. That's how many of our secondary lines to our openers have running off of each of our primaries. So everything's green in this circumstance. Things are good. However, if we were looking at something like this, that means every single run on the cart is blocked, and that wouldn't be a good time. Probably means you forgot to turn the fan on or something like that. Okay. Now, we can also disable them. So if we had issues with a sensor, things like that, we can actually go in and disable those towers. One of the ways that we can do it is when we're in this full run page for it, we can simply tap the center of here and it will disable the sensors. Yep, and we do have the ability to disable by individual sensor on each of the secondary hoses, not just our primary blockage sensor. Okay, so we can also make them inactive, so we can just straight up turn them off if we didn't want to use them at all. We also then have orange, so that means unexpected flow. So this is where if we had seed trickling through, we mentioned earlier, you know, where if our hoses were sagging too much at certain places on the drill or on the hitch, and we had some seed or stuff pooling there, you might raise the tool up out of the ground, and some of that product might still trickle through those low spots and go past the sensors. That would be an example of where we might see unexpected flow. Okay. If everything's all grayed out, that's missing or extra. So generally probably not going to see extra, but that probably means that, you know, one of our sensors is offline. We could see a whole node or a primary offline as well. Okay. I won't go through the setup a whole lot here with it, but we do have our sensitivities there at the top for our top and our bottom chute. So we're going to adjust those guys kind of based on our seed size and our seed rate of how much actual product is going through there and how sensitive they are. Obviously, we don't want it beeping at us all the time, but we still want it sensitive enough that if we do have a blockage, it's going to detect it. So. Now, one of the things that is good is inside our advanced settings here, we do have the ability to go in, and this is where we can set in things like our delays or reminders. So the reason the delay is nice is so that it doesn't just engage immediately if there's a blockage. There's a bit of a delay in it. The alarm reminder is that if you've silenced a red one, it'll stay passive for 30 seconds and warn you again that it's blocked. And then the two below it, the master on and off delay, that actually ties in with our section control. So we're generally going to set that to 5 or 6 seconds because we don't want those guys set immediately. So as soon as we start seeding, it's looking for seed because it's going to take time for that seed to come from our roller and our meter housing all the way to the actual secondary where it's going past the sensors. So One of the things that is nice inside the display is if you hit this information button over here, the I button, it does give you a breakdown of what a lot of the colors and diagrams and stuff show on here. So some of the things that I see most of the time I have questions with guys is what the bar underneath each primary means, and then what the black circle around the primary means. So what we're looking at with that black circle is that is our product flow relative to other primaries on the bank. So that means if the black one of your primaries, that black circle wasn't filled in as even, that means we could have restricted flow to that primary. So that could be an example where maybe we have a partial blockage. Maybe we've got some bridging in our roller, something like that. That could be an example of that situation. Then the bar underneath, that's an example then of the product flow of the lowest row on the tower. So we're going to want those guys to all be filled right up. But if we had one of those bars filled all the way down, that's where we might have a partial blockage then in one of our secondary lines, not just a complete blockage. So it kind of gives you a little more information to see as opposed to just, is it blocked or not? Okay, that's part of the whole relative side of things. Now, one of the other things that we can do is you'll often sometimes see this black arrow on here. So when we see a black arrow underneath, what that means is it's going to be scanning through our primaries. So it's basically just going to start going from 1 to 2 to 3 to 4 across the tops, and then it would rotate and go through the bottoms and then circle back through again. Okay, if it was a white arrow underneath, that means that you physically tapped one of these buttons, and that's what's going to be showing down here on the bottom when there's a white triangle. So. Okay, just an example of more blocked. And then here's an example of that white arrow, so we can see it showing that we tapped on it. So we can see that we're on primary B7, and that's what's showing up down here on the bottom. Okay, so our next slide here is going to show an example of what a full primary blockage is going to look like. So we can see that the full circle is red. Our black circle on the outside of the primary is completely gone. So that means it's not relative whatsoever to the rest of those primaries. As well as then we can see that each one of the secondaries is also registering as blocked as well with no flow. Now, if we had just one secondary blocked, this is more or less what it would look like. We can see now B3, our primary, is still flashing red. We've hit it so we can select on it. And here it's showing now that 5 is partially blocked or having a problem. And that's indicated down here too, that we have one or more that is running low with that bar below that primary. Okay, and in this case, we're looking at a complete blockage. We still get our wonderful pull page warnings, which hopefully that changes someday. There are blockage reference guides, which is a lot of kind of what I went through here. That should have came with any of the new drills that came with blockage. I'm going to try and share some PDFs of TruSet setup, blockage setup, and a cart quick reference guide in the meeting that you guys should hopefully be able to download as well. I'm going to share that once Connor starts presenting. But the last thing I'll go over here now before we go on break, or one of the last things here, is our end of season storage. So this is one of the questions that we had from you guys when you registered, which we really like that. When you guys ask questions there, it gives us time to really try and make sure we come up with a complete answer for you guys. So generally some of the best practices we can have for that is we're going to recommend blowing all the product completely out of our tanks and out of our meter housings. So taking all of our foam strips out, taking out those plastic housings, opening up the bottom gate, taking our meter rollers out, making sure those guys are all clean and blowing it out. The next thing that we usually recommend is to clean it with water. A lot of guys in the past have sometimes used diesel fuel, but that's hard on the seals and the foam in the meter housing itself. So that's why it's generally not sometimes the best for that. But then since we're going to use water in there, we do recommend to actually actively blow and dry out the meter housing. We don't want to leave anywhere where moisture can sit and pool inside that metering assembly. So we can do that, get your trusty leaf blower out, run your fans, things like that, to try and blow out the inside of that meter housing as much as possible. Then what generally the next best practice is, we want to take and fill the meter housing from the top with floor dry or kitty litter. Now, the next step varies a bit depending upon how you store your rollers. If you store your rollers in the carts, then it's not a bad idea to just go in and turn the rollers, get some of that floor dry into the meter housings, let it run through, make sure it's nice and full where that floor dry and kitty litter can soak up moisture so that it's not sitting on the metal. Then but if we don't store the rollers in there, there are those plugs or caps that you can put on there. And you don't have to store your roller in the cart over the winter. Generally speaking, I would recommend not storing the roller in the cart over the winter. I would recommend taking it out and using the covers. Obviously, other parts too then is, I mentioned earlier with our rollers, we want to store them. If they're out of the cart, standing up inside our shed or our shop, obviously we don't want to leave them outside. And again, good practice then, end of the season, take the roller apart, clean it, check your rollers, your brushes, all that kind of stuff, your tuning rings. Your conveyors and augers, obviously make sure they're good and cleaned out and empty. There's clean out doors on the conveyors and the traps. We have seen in some circumstances guys like to wash them, and sometimes when moisture gets in there, the belt can get stuck to the tube, and then worst case scenario, when you fire it up in the spring, it actually has broken a belt. So one of the things we've actually discussed amongst the product specialists is one thing that might be worth trying is running some graphite with it. So put some graphite in the bottom, let it circle through around the belt, coat the belt a little bit, and that might help prevent it sticking to the tube inside the conveyor. That's one of the reasons why we don't recommend detensioning the belt over the winter, is we don't want it to get loose or maybe sag and get stuck to the tube with it. The other part too is, and this one's even in season as well, is don't forget to lubricate the meter drive chain on the right hand side of the carts as well. And it's probably a good idea to grease the pivot points for the conveyor moving as well. So last but not least, I just have a couple more slides. Here's our shameless plug, we'll say, for today. Is some of the optimized pros that we offer as the product specialist. So if you guys need more help, or if you've just bought the drill, the odds are we're coming out to help you anyways. But if you've had the drill for a few years and you'd like us to have a fresh overview of the cart and the tool, we can come out and do that with you guys in the yard, make sure things are up to date, make sure things are in spec, everything's not worn out, go over some training, stuff like that. We can do that with you guys. So those are options. And then the other part of it too is our service guard inspections. So it might be getting a little late in the year for that. They might be buried back under snow where they weren't a week ago. But it's generally not a bad idea. You get an inspection done on the cart. There's some good benefits in terms of the parts and stuff on it. Make sure the cart's in as good a shape as possible before you hit the field. So to minimize some of that downtime. And then this isn't technically my last thank you slide, but there is just kind of the map here showing our dealerships, and then we have the numbers there for our solution specialists. So you guys can kind of take those down if you like. But with that, unless there's any other questions in the chat, it is 9:58. So at 10:05, we will pick back up again. So I'll give you guys like 7 minutes or 6 minutes to grab a drink, stretch your legs, a coffee, and we will get swapped over on our end, and Connor will start presenting from the simulator.
Morning, everybody. I'm going to go over using the simulator this morning, bouncing kind of back and forth between the 1910 carts, hydraulic carts, and the C series carts. Some similarities definitely between the two, no doubt, but certainly an awful lot more information available with the introduction of the C-Series carts. So my plan is I want to go through basically homepage navigation and what you can see there, then going through setup of the cart, then go through some system tests and maintenance and where to find those things, then go through basically meter setup and go through some of that stuff. A little explanation as to ActiveCal verification, where you would find that, different ideas as far as calibration, and then last but not least, just going through our setup as far as getting our crops set up and that for documentation. So First off, we'll start off with the 1910. As you can see, I always like to start from the top of the page, but basically there's your bin level sensors right up on the top there. Then you can see that your variable rate steps, plus or minus, your clutch, manual on and off for each individual tank. Then underneath that, you can see in this particular case with all green there, that's basically looking at our section control, and all meters are on. Certainly underneath that, you can see we've got our variable rate set up in there, where you can go and set up different variables throughout, acre counts, and cart speed. This hasn't changed. That's our main drive that we can manually override. We can also, of course, there's the implement switch, and we've got section control. Homepage here, then now we've got our fan setup, and Matt had gone through some of this. So in that box there, that's our top chute, which would be, in this particular case, if a double chute machine, that's going to our right-hand fan as we're sitting in the seat. That's our little higher output fan that we have there. There we can put in our target fan RPM there. And then, of course, the bottom chute, which is our for our seed runs. On the 1910s, it does give you an indicator as to those lights that Matt was talking about. That's been with the right back to the 1900 carts with customers that didn't have that hydraulic control within the cab. They put the lights on there, so it was a little bit easier to be able to adjust with the old rabbit and turtle adjustments on our hydraulics outside of the cart to be able to get there. You'll actually see your actual fan RPMs down below. So switching over to the C-Series cart, all of a sudden you see it, it does get a whole lot busier here. Going back again, but looking on the right-hand side, you can see those icons. A lot of similarities there. Our home page, our meter setup, cart setup, totals page, and then a wrench or our maintenance or diagnostics. On the C-Series cart, very similar, but all of a sudden we start to see a couple of extra icons there as well. So Matt had talked, and he had a slide there. There is an I button up at the top. So there you can actually see where you're seeing my little X. You can see your tank pressurization and where that is for your front or your mini, sorry, front, middle, and rear tanks. Also on this page here as well, what they do and have incorporated with the C-Series carts is you can actually do a target fill with it. So you can give it a fill. Now that we have load cells on the C-Series cart, you can actually give it a target and use that as a target fill. Get back to our home page. So again, very similar here in that we've got our variable rate step, where we've got a plus or a minus. There is some setup involved with that. They do put the little spinny wheel there on each individual clutch itself, where you can actually turn that on and off, which shows you that meter is actually turned on. It actually shows you as well what, according to your setup, which roller you have in each one of those tanks as well. The fan setup is very similar to what we had. Again, top and bottom, just a different place to go and find it there. The main drive clutch is still there for you to be able to manually turn that clutch on and off. Cart speed, acres covered. The other one here that we have is actually our the C-Series carts do come available with the brakes on them. If you have a Deere tractor and you've bought the tractor brake kit per se, when you're actually using the brake system within the tractor itself, it is using the tractor brake and the cart brake Am I correct when I say that, Blair? Okay. And if you don't have that that cart or tractor brake kit, and just want to actually use the cart brakes, if you actually manually press that, you're actually just engaging the cart brakes. So that's basically going through those home pages. And again, like I said, you've got a totals button, you've got your diagnostics wrench, you've got your section command, you're going to see the ActiveCal button and also an alarms button there on the C series. So next thing that I'm going to switch to is let's go through basic setup of our cart. We're not going to get to meters quite yet. I wanted to go through a few things here as far as the setup of the carts themselves. So on the 1910 series, if I go down to cart setup, you'll see there that I've got on my upper tabs, I've got cart, I've got tool, and I've got sensor. And if I go into the C series and go to that cart setup, virtually the same there as far as cart, tool, and sensor. So going back to the 1910, basically we've got the simulator set up as a 550 cart. It's using a height sensor. Choices there, you've got height sensor and you've got a can height sensor. Anything that has TruSet on it, you're going to want to use the can height sensor because that relates to basically the TruSet controller that's on the machine. Anything else that you are using there, you're going to use the height sensor because it's basically just using a potentiometer. So the can height, it's linked to the what am I trying to say, Blair? The help me, Matt. The can height sensor is related to the TruSet. Thank you. Sorry. So there we go. We go back into the C series. That's virtually the same. Again, choices there are can height sensor and height sensor. So going back to the 1910, if I went to tool, the simulator that I've got up, and I'm running two here. This particular one is an 1890 50 foot. There's our width. We've got that set to 7.5 inch spacing on that. If I went ahead and started to take a look, the 1890s, it's going to be a single chute machine for the most part. So you'll always see that as a top chute. And you're going to see those check marks. So that would be an indication, am I using all three of those tanks? Pretty much once you've got it set up, John Deere's done a pretty good job. It virtually populates how many of those secondary runs is on that machine. Very, very important. In the early years of the 1900, we had to manually put all of that in. It was a little bit of challenge back in those 1900 days, but machine will not calculate if it doesn't know how many runs that it has. So from the tool perspective, that's there. If I flip over to the C series cart, you're virtually going to see that same thing here. In this indication, though, I've got this set up as an 1895, or what we would refer to today as an N560F, where we're running double chute. So again, depending on N560, whatever, the top chute is going to be configured as to how many secondaries, so how many openers is on there, and then the bottom chute. Remember that an N560, we're on 20-inch spacing on the top chute, and our bottom chute is going to be on 10-inch spacing. Very, very important to remember where we've got bottom and top, bottom and top. That is how the machine is calculating, and I'll get into a little bit more of that when I get into that meter setup. But make sure that if you are switching tanks around, that you also come back in here and make sure, say you were using a tank previous as a top and you were switching it to a bottom, make sure you do that because it's calibrating our meter displacement value according to how many openers is on there. The next is sensor. And what do we have here? So any air cart that I'm working with, and I think it's very, very important, Matt brought it up in a few of his slides, whether it's a new cart to you or whether it's a last year's cart that you're bringing out of the shed at the start of the year. Wheel inch, in my conception or belief, is very, very important to get that dialed right in. In the early years, what they wanted us to do, we used to mark out a 400-foot course, unfold the machine, run that about 5 times, and then take the average of that, and we use that as our wheel inch. In your owner's manual, there will be a base wheel inch, and you want to make sure that you at least start there. The key being how much air you're running in that tire itself, and everybody's going to be different as to what they're using that. You want to make sure when you are calibrating or figuring out what that wheel inch is that you've got the cart half full, so halfway between full and empty. That's going to affect the amount of squash that is on the tire itself and kind of hit that happy mean. One of the easiest way, and with more and more GPS coming into play these days, I like to use GPS speed. So you could actually, if you had an extended display, have your GPS receiver, which is going to give you a ground speed, and then you can just play with this, wheel inch number. And I search for trying to get that 0.1, 0.2 miles per hour close to the corner post or the speed readout on my tractor itself. So very, very important, I think, that you get your tire speed calibrated. That's one of the first things that I'll do with customers when I'm doing startups. Same thing here. Going to virtually look the same within the C-Series carts itself. So going back in under sensor there then I can set my height and tank pressure. I can zero that. So there's where I would be going in, and if I was getting a reading there and yet I was not running the fan or anything and I was still getting a reading in there, you can actually go in there and actually zero that tank out. In the C-Series cart, when we open that up in under sensor, now all of a sudden we start to see a whole lot more information there in under the C-Series cart. So that can height sensor, making my choice there, knowing that I do need that can height sensor. So now I can either have that set up as a common threshold, so a common turn on and off or start stop. It'll give you your current tool height. If I take that check mark out of there, then you can start separating those as a start and a stop. So that's in under can height sensor. There's the tire speed. I know we had a question there from, I believe it was Ron Cron, asking where we can go to zero out that scale. Right now, my simulator is basically showing me that I do have weight in that cart and in each one of those tanks. But if I do go to that tank scale, then hit that arrow, there's where I can go and I can zero that out. So all I have to do is hit that for each one of those, accept it, and that's how I can zero out my scales. Tank pressure, again, within the C-Series is another option there where we can actually go in, click all of those. If I'm getting a reading and I don't think that I should have a pressure reading there, I can go hit that and it will actually zero that out. Any questions there, Blair? No, all good. Okay, so we've gone through virtually our setup on both our 1910 and our C-Series cart. So I'll go back to our home page. Next thing I wanted to talk a little bit about was some system tests and some maintenance. Again, we're pulling last year's machines out of the shed, or even if we're working with a new machine. So on a 1910 cart, I would be going to that diagnostic icon or diagnostic wrench. Little different process here. Then it takes us into system tests. So at a 1910, it gives me this. I've got to accept that. So there I can start to see some voltages, some pressures for in the 1910 front, middle, and rear tank. If I moved ahead, now I can actually, those lamps that Matt was talking about, I can actually turn them on, turn them off for both the top and the bottom. Little test so you can visually take a look at that. Now you can actually take a look at your tire speed output, your fan speed output, sensors on all of those, your tank level inputs, so your bin level sensors. Here's one that I think is very important for all of you to know, is because we have a hydraulic cart. Whenever we're incorporating, say you had a last year's tool and you're putting a new tractor on it, or just good practice at the start of the year, I like to make sure that customers go through and know where to do a motor flush. So at a 1910 where I am, I can basically take all three, front, middle, and rear tank. I think it gives me a maximum of 20 seconds there. I can take an OK. Then all I'm going to do is I'm going to take a start. And basically what the system is doing is it's just ramping those hydraulic motors open to wide open. We're getting rid of any air in the system or any contaminants that's there. I like to do that once I've actually heated the oil up. So I'll run the fans for a little bit of time and then, you know, go through that first thing in the springtime, and I'll do that 5, 6, 7 times. Not a problem. So there's where you would find flush motor. Other things that are there on the 1910, you can actually give it a target speed. So if I did that and I could just do one tank, I'll just do one tank for, and let's see if it actually hits RPM. And there in the simulator. So that way you can kind of take a look at your speed sensor or encoder on the meter itself and see if it's actually hitting target. So you can do that. 1910, you can do 50 RPM, 10 RPM. Calibrate valve, something that we generally check. John Deere used to have a video up for us in which they will tell us how to go about calibrating this valve. It's not something that you guys would generally do. The whole idea here is that you're going to see a target of somewhere between 115 RPM and 125. I believe that the general running speed of that is going to be about 120 RPM. So if you're within that range of 115 to 125, you're generally good. I like to see them around 120, not necessarily mandatory there, but if you start seeing that really low or very, very high, you should probably get a hold of your solution support or your service department and go through and get that set up and taken a look at. So that's basically, you know, some maintenance on the 1910 side. On the C series cart, same type of idea.
Just had a question on chat corner to point out the weight.
On a C series? Yep. Yep. So there's your weights. Sorry, I missed coming back possibly to that, but there's your weights actually on the C series cart. There.
Yeah, you see it on your run page.
Yep, you'll actually see it on the run page. Of course, we don't have load cells in the 1910. Thanks, Matt. Getting back into the C series, flipping back and forth between the two. Here we see readings. So you can see readings again for tank scales, for brakes. It's more of a site for diagnostics more than anything. Tests, here we can actually see a meter test. Matt had talked about a sectional test. I'm not going to talk about meter verification right now, but that section test, there you can actually, just for your front tank in this particular example. So you can choose whichever tank it is that you want, the mini, front, middle, or rear. You can switch that over to there. There you can actually see some diagnostics as to whether those plungers are actually working, right? So I've actually got to hit that start button. Now I can put the checkbox in, showing me closed, gives me some status. So I can go through each one of those and see if that plunger is actually functioning within your section control or section command, I guess I should say. Tests, so that's one. So there is a meter test there as well. It's more of a diagnostics type of thing. System maintenance, though, we were just talking about meter valve calibration. So that's same principles, same idea as what we had in the 1910. There's the crack point, and there's the meter flush as well. So again, I can, within the C-Series cart, I can actually do that meter flush as well. I can check all four. I can do them all at once, or I can do them individually. Sound good? Okay, no questions there, Blair? Everything? No? Okay. So next thing I wanted to go and just kind of progressing through as to kind of how I would approach it and the things that I would be checking, working with my customers when I come out. Next thing is going to be going into our meter setup. So from the 1910, we're going to see a lot of similarities here between 1910 and the C-Series carts. So again, the tabs up at the bottom, we've got a setup button, we've got a cal button, and we've got variable rate. So setting your cart up front, you're going to pick which tank, you're going to pick the product. This particular one has fertilizer in it and type. One of the things that you're going to see that's going to change here from the 1910 to guys that have moved over to a C-Series, here you're actually going to see a rate that you can put in there as to what your target rate is. And there's that variable rate step. So that one is set at 1. So just to give you an example as to how that looks. So there you can see that 48 pounds to the acre that I had. If I click that 1, all of a sudden you're going to see it's just going to move up that 1 pound that I had put in there. If I had that at 2 or whatever else, that's what it's going to show up as. So go back to your meter setup. Very, very important. I think that we make sure that, you know, we go through this all of the time. The 1910s, like I say, with the rate and the variable rate step, the machines, there's more and more technology built into the machines, but you still have to physically tell it which meter roller is in there. So make sure that you've chosen the right meter roller. MDV, question that comes up for people that are new to a John Deere cart. What is MDV? So that's meter displacement value, and that is actually pounds per 100 revolutions of the meter per row. So I talked to you about the importance of in the cart setup as to knowing how many secondary runs is on that machine. So that is what it is relating to. How many pounds per row every 100 revolutions. That's what that MDV is about. So once we've gone through that on the setup page, if I moved forward, there you can see that I've got a previous, I've got a standard, and I've got a custom. I'll talk about that a little bit when we come back to, I just want to go through the C-Series cart. So if I went into meters, you're going to see virtually the same thing there. There's that MDV. There, when we move over to there, there is standard. So when do we calibrate? Why do we calibrate? I bet you if I pooled and we set out to everybody that was here in the group, everybody has a different way and a different approach as far as calibrating. There are some people that are going to calibrate right in the yard and then head to the field, seed for a while, do a couple of headlands, and then maybe do another calibration. The question that I will always present, and another idea, and we talked about that standard value. So let's use an example of we're doing hard red spring wheat and we're seeding. The MDV that John Deere puts in there is based on a 60-pound bushel. And that's what we're trying to figure out, is what our new bushel weight is. So again, some people are going to calibrate in the yard every year because they know that their bushel weight is going to change, or they may use a last year. If you had last year's drill, you finished off, you had a really good rate from last year, you could use a previous MDV as a start, go and seed a couple of headlands. The idea of seeding and then doing a recalibration, a lot of people think that it's just about actually getting everything in the tank to settle down. It's actually, it's that for sure, but it's also a combination of getting that meter fully primed. So if you're doing a calibration in the yard and just going by the directions and the suggestions that they give you, I would suggest that we're not going to get that meter primed. And I've seen it over and over and over again. After doing a couple of headlands, you'll actually see that MDV actually change, because the meter gets more and more packed full. So it has more coming out, which is going to change your transmission setting. So that will change. The other thing here, because we're in the C-Series cart, you'll see now I don't have the ability to put a rate in here. All I have is that variable rate step. So once I've got my cart all set up, front, you know, in this particular case, mini, front, middle, and rear. If I'm going to, on a C-Series cart, I need to go to variable rate. And now I have to start inputting my rates in there and turn that on as another prescription or rates that are available for us. Okay. No questions here yet? We're doing okay? We got it.
Yeah,
Okay.
we're just gonna, there's questions coming in, we're just gonna answer them as they're coming in.
Okay, sounds good. So MDV, I talked about calibration, when and how we should or how we can go about doing it. The other thing is with the 1910s, showing you where I would go. It's going to be pretty close to the same on a C850. So once I've got my setup done, I go over to my calibration. I can do 3 tanks at one time. So I can put the checkbox in there. I've got all my setup done. Then I hit my go ahead button. And here's what you're going to find coming up. Install your bags. Enter desired calibration meter RPM. They did change that 2 or 3, 4 years ago, where they gave us the ability to slow the RPM on that calibration down for bulkier seeds, soybeans, those kind of things, and speed it up for small stuff. Good point, Matt. Here it says, turn the meters 2 revolutions. So this is where, again, different ideas. If you're doing that and you're just going to calibrate straight into the yard, I would certainly think and suggest I would want to do more than 2 revolutions. Make sure you prime that meter good. Then empty it and reinstall the bag. Press continue to start the calibration. There I would go. Then I would go back to the machine and hit my toggle switch. You're going to see that the meters are actually going to start to spin. So it's going to count your revolutions, and then it's going to ask you a weight for each one of those. So in under the C-Series cart, calibration doesn't look a whole lot different. Again, I went from there, same type of description on that. Use what works best for you. I think that's, the end of the day, probably the best practice as far as calibration is concerned. What else have I got here? So then we can talk about verification on the flipping back to the 1910 cart. To do, once we've done a calibration, you can do a verification. So after you've seeded those couple of headlands, or even if you're in the yard, you can do a verification On a 1910, I would go down to my wrench. Actually, sorry, the 1910, I want to go to totals. I'm going to go to calculate. There, I'm going to go to meter verification. One of the nice features that they've done for us is they gave us the ability, there was from the old mechanical cars where I was actually counting crank turns. It will simulate speed and area covered, so I can tell it that I'm doing it in a stationary mode, how many of those tanks that I want to do, and give the area that I want to simulate. So if you were doing wheat, for example, you probably 1/10 of an acre is probably good enough. What I like about this is if I'm doing canola, I can simulate a half an acre or an acre. The more weight that I can, or 2 or 3, like Matt says, yeah, more weight I can catch and get in the bag, especially when it's windy out. The more of a sample I've got, the easier it is to check. So verification there is, that's where you're going to find that on the 1910. If I went into the C series, it's in a different place. You remember we looked at totals in under the 1910. For the C series, if we're going to do a meter verification, it's in under the diagnostics wrench, in under tests, and there you're going to find meter verification. And there's a couple of other, one other thing that I want to point out to you here as well. So if I want to do this in a stationary mode on a C series cart, if I take that, all of a sudden those two windows pop up. One is going to be speed and one is going to be area that I'm going to simulate. Then when I start checking these boxes off, if I were to do that, let's just do one. So first thing I'm going to put in there is, let's put a speed in, let's assume 6 miles an hour, and area, I'm going to do like 0.2 of an acre. All of a sudden you'll see the start stop button. And a number of us have been caught on this one, thinking that we needed to hit this start stop button. So you've got the start stop from the cab. And like Matt said, if we're going to start a verification, this is a verification, but you can actually hit that start stop button in the cab and it will actually rotate those meters before you ever get out of the cab. We've had a couple of examples where guys hit that thinking that that was going to start that verification, then went back and hit the remote switch on the cart itself, and all of a sudden he had more product there than what you wanted. So my thoughts would be, and most of my customers with C-Series carts, I think we've been doing both calibrations either from the cab or from the side display, like you say. But if you're doing a verification, just remember that if you're going to start it in the cab, those meters have already spun. They'll be finished by the time you get back to that cart. So something to be aware of if you're doing a meter verification on the C-Series carts. Okay, so the next thing I think that we should talk about, and one of the nice features, 1910 carts, of course, we don't have load scales, different design there altogether. But for our C-Series customers that are in the session itself, you'll notice that you have the ActiveCal button here. So with the introduction of the load cells, and it comes back to when do we calibrate? Again, lots of different ideas. I've had guys that will start with, say, last year's, cal values that they had, or they'll do a couple of headlands, get a good cal number out of there. They've made sure that they've got that meter primed, and then they'll go to ActiveCal. So ActiveCal, basically it's going to, if you just read the page, it's going to basically tell you exactly what you need. Stop the cart complete on a level ground to record initial weight and the final weight. Keep the meter enabled during the calibration. For best accuracy, calibration should be completed when tanks are greater than 50% full. And I think really what it wants to see 1% of the tank weight is required to complete that calibration. Okay, so once you got there, basically you're just going to click to the next page, click tanks, whichever tank it is that you want to do the ActiveCal with. So let's just say we were doing the front tank. Then we're just going to hit the start button, go seeding, and basically seed out, and it's going to calculate as it's rolling along. Because the simulator doesn't show it, it's going to show you how many acres that it's covered, and it's going to actually show you how much weight that was used there. It'll figure out, it'll say, okay, I've got a new value for you. So you'll see that it'll have a new displacement value. So I've got guys that will use ActiveCal after that initial, and they will keep on doing those ActiveCals. All it requires them, really, you don't have to stop right when it gives you that new message. You can wait till you get to the end of the headland, accept that new cal value, and they'll do that 2 or 3 times until they all of a sudden see that displacement value no longer change. That tells me that they've got everything primed up and they've been extremely accurate. So it does take, you know, that verification. Guys have done a lot less verification with the bringing on of the ActiveCal. One thing that I will say, if you are doing canola, for sure, do calibrations and do manual calibrations. Matt talked about it in his little presentation, and one of the things that we saw last year, being so windy last year with the scales, depending on whether you're, you know, catching side winds or whatever else, and because our rate was so small, it wasn't seeing a whole lot of change. So it took an awful long time for that ActiveCal to actually figure itself out. Plus, with the wind and the scales, we could see that that weight within that bin was just fluctuating. So it was really struggled to get us that final cal. So the easiest process that we did there was we just went back, did our manual calibration, seeded for a while, did another calibration, and did a verification, and it worked out great for us. So just a thought there as far as ActiveCal and doing canola. So the other thing that you're going to find on the C-Series cart, and I'll go back, is we also have this alarms button here. So we can go into alarms. So we can take a look at it, trigger select, tank almost empty according to tank scale, and I can give it a threshold as to the, once I see approximately this amount of weight, that I'm going to get an indicator that it's, you know, I'm getting down in that. You can also look at it from a bin level sensor that will give me an alarm to start taking a look at maybe refilling, or it can also take a look at area to empty. So that's just where that, with that alarms is about there with the C-Series carts. Totals, there again, I can take a look at totals, and I can look at meter totals. They do have another calculator. We can calculate actual flow within that. Not one that I've used, and I don't know, Blair, if you've ever used that one or not. If you had any, yeah, it's not one that's used a whole lot there. So from there, from our meter setup, then I'm going to talk about and section command. So section command, both on a 1910 and on the C-Series cart. To get to section command on a C-Series, you've actually got an icon there. When I go to the back to the 1910, I can get to it a number of ways, but one of the ways is if I just hit that home page again, there you'll see your section EQ numbers. So what is section EQ? It's the introduction of section control when we first had 1910, or it first came out in 1910 carts, was that we didn't. So with the 2630, we could basically account for the differences between each of the tanks, but what it didn't account for was the length of hoses. To our longest ones, on our outers and our shorter ones on the inners. So what we ended up getting was basically a chevron effect. And it was kind of tricky to get that all balanced out. So Deere introduced what they called section EQ. So we can check both our outer on times and our outer off times, also our inners, in other words, our shorter runs, both on and off. So where do we come up with those times? I guess the suggestion and what we've done sometimes in the past is get two people, one person standing by the tool, go to the farthest if you're checking your on times for your longest outside runs, is somebody standing at the outside of the tool, farthest opener away with a stopwatch, and somebody with the fans on at the cart by the meters spin. So to get my turn on times with fans on, he could just cycle that some product, allow that to flow out with his arm, wave to the guy, and as soon as that person on the outside starts to see material, there he's got a time for his outer ons. Then to get your offs, now you could do the opposite, which is, again, start the meters to turn, then the person indicates when they've quit spinning the meters. Now you can run a stopwatch and basically figure out what your turn off time is when you no longer see any material. Yep. Okay. Okay. Or okay. Yep. Okay. So that's what section EQ is all about in the C-Series cart. Same type of idea here, except when you get to your second page, when I move forward, and there I kind of put in some examples from numbers that I had collected over time. You will notice here, though, on the C-Series carts that your inner offs are no longer there. So we've done some calculating and figured out some. I think most of the solution support guys have kind of some base numbers that we input there to start with. Really starts to, the thing that you want to remember with your section EQ is once you've got those numbers in there, leave them there. Those should not change over time. Where do we go and adjust those? So for both the 1910 and the C-Series cart, when I go into setup, now I go in under my equipment and I go to air seeder, cart, here, this one is a tow behind. So if I went in there, now you're gonna see all of your setup, your measurements are all in here, etc. Here, when we get into our mechanical delays, the best thing you can do is take a picture of what you had in the section EQ, because what this wants to see is it wants to see your outer ons and your inner offs times. So you can input those. And then how do we go about fine tuning that? Well, right from this page, I can go to performance tuning, and I think this is a really nice thing that they've introduced. Rather than trying to figure out those times and balancing those, you can do the performancing tuning. So if you're flagging your headland, I've generally, raised the closing wheel, taken the depth out of it. So I'm just dropping seed on the ground, do one opener, do an on and an off. Now I've got those, take my tape measure. It's going to ask me, what did I see? Did I see a skip or an overlap? At what distance and how fast I was going, and it will automatically adjust those times for us. So that performance tuning is been a really good tool. The other way that you can get to that and do some fine tuning is actually going into your section control. So if I went into section control, there's my master. If I went into my overlap settings and I go into my coverage overlap, now I have the choice of overlap plus additional. So if I clicked on that again, now I can, rather than constantly changing those numbers, I can add distance or subtract distance to help fine tune to get the overlap that I needed. So just another way of going about it. The importance of measurements, again, when you get back into your setup button, section control is only as good as the measurements that we have in here. So take the time to go through, make sure that you get your center of rotation. On a N560, you're going to have 3 of those settings in there. There's going to be different measurements for both your mid-row and your seed runs. Take the time, like I say, to pull out the tape measure. The other one that I want to cover before I finish up here is this tank configuration and getting into documentation. So people have different ideas and different practices, of course, how they want to go about. I've got some people that will have 2 tanks with the same product in it, and they're turning one on and turning one off, or we're doing them individually if I've got different products throughout. So make sure you choose the proper one here as far as your setup. So if you were to choose individual, apply different products from each tank. So that was, if you had different tanks. And I know what we've done for something with a mid-row, an N560F, where I'll have the same fertilizer, but in 2 separate tanks and one going to the mid-rows. Our field advisor will actually name that, such a product MR, and then such and such a product seed row. The other one is a alternate switch between tanks of the same product. And then there's merge, where I'm trying to get those tanks to evenly move down. So just to show you, if I went to alternate and I switched that, and then I went to next, there you can say that I'm alternating between those tanks. It gives me those choices as to what I wanted to do. When I go back into there and go back to that alternate, all of a sudden it's showing me that those tanks are the 2 products and that I'm merging those together. If I went into merge, trying to get those tanks to come down at the same time, now we can start working with percentages. So, 20, 60, whatever percentage that you want to put in there. So that's pretty much what I wanted to cover, Matt and you guys. I think I've pretty much got everything there that I wanted to do. So with that, I'll pass it on to Emilio.
My name is Emilio Perez. My title is Production System Specialist, which probably to you doesn't mean much, but essentially it's the product specialist. So I'm one of the Deere representatives here in Manitoba, and I support Enns Brothers in Green Valley when it comes to product knowledge, demos, startups, and training. So you may see me out in the field once in a while or hanging around the dealership. So the 2 main things I'm just gonna quickly cover here. I know we didn't touch much on the tool, but there is some naming and numbering and just all that's associated with it that's changed. And I just want to make sure everyone's on the same page there. And then kind of the TruSet falls into the what's new category. So I just want to get you a little bit up to speed on the new run page and just do a kind of a high level overview of it. Okay, so when it comes to tool naming and numbering, so just to give you a little context here. So if you hear some of this getting tossed around the dealership, you got your old naming conventions here and then your new ones. So the first letter, and say the example here is the N540C. So the first letter is your opener type. So N is for no-till. H is for hoe, and P is for precision hoe. And then the next letter, and here is just the series, so it would be 5 series. And then your next one here, your 40, so that's your tool width. And then the last one here is your differentiator. So F would be for fertilizer, so for tools that have the separate fertilizer placement rank. And then C is for that central commodity system, otherwise known as CCS for short. So TruSet, just to provide a bit of context, if you're unfamiliar with what it is. So TruSet's a downforce system that allows operators to set downforce pressures from inside the cab instead of having to get out of the cab and manually adjust the valve on the tool. So with this, it can be easily adjusted by the push of a button as soil conditions vary. So the range of that downforce adjustability begins at 74.8 kilograms, so 165 pounds, and tops out at 181.4 kilograms, so 400 pounds. So in order to use TruSet downforce control, it requires a Generation 4 4600 command center display, or the Universal 4640, or a Gen 3 2630 display. And the software is compatible with extended display setups in each case. So around this time last year, TruSet was only available on the N500Cs. However, it's since been added to the N500Fs and the N500s, formerly known as the 1895s and 1890s, respectively. So originally, when it was first implemented, it looked like this on the display, whereas nowadays it looks more like this, and it will vary slightly depending on whether or not your setup includes fertilizer placement ranks or not. So on the top, you can see this is what it looks like for the N500, and this is what it looks like for the N500F. So just the difference is just in this tab here. So to get to this run page, what you have to do, you click on ISOBUS VT menu on the display just at the bottom bar, and you'll notice that the run page is divided into 4 parts. So you got the TruSet module is at the top here, and then the presets module is at the bottom left, and then the opener module is at the bottom right. And then the right panel here has 3 navigation buttons. And so in the next few slides here, we'll just run through each one and just make sure everybody's on the same page there. Okay, so first up, with the TruSet module, with the run button chosen in settings, the opener module shows the pressure status. So the text box is white when not activated, green when activated, and yellow. And yellow when temporarily adjusting using the SCV flick mode. So the number inside the text box is the target downforce, this guy here, the 300 in yellow. The number below the text box is the downforce being applied. And then below the applied downforce is the pressure increase button and pressure decrease button. So pressing one of these buttons changes the target downforce by the increment adjust number assigned to that button. And then below the run button is the opener button, which brings up the settings module for the openers. So here you can input increment adjustment amounts for the increase button and decrease button. The targets will change by this amount with each press of the button. And then the height sensor that will be monitored for the rank can be assigned just right here. And then the opener alarm button allows the operator to change alarm timer. So you just click on this guy. And then press the run button to save and close the opener settings module once you've adjusted everything in here. And then when you click on that opener alarm button, you get your downforce disabled warning delay, which starts when the openers are lowered below the starting point, and a warning will be sent out to the display if the hydraulic pressure is not available for applying downforce. And then the failed to reach set point timeout starts when downforce is activated. So a warning will be sent to the display in the same manner. And then next up, we have the opener module. So in this one, the SCV assignment is shown at the top. Completing the SCV assignment. There we go. Oh, yeah, it popped up good. Okay. And then you have the target pressure, which is shown here by the yellow bar on the gauge and inside the text box. And you have the applied down pressure, which is shown on the gauge and as text box below the gauge, just right here. Then you have the increase and decrease buttons, which change the pressure on all openers by the increment adjust amount. So when the openers are raised, applied pressure goes down and the target pressure box turns white, as you can see right here. So the next module is the presets one. So TruSet downforce has 4 target pressures presets, which are configurable by the operator. So to make changes, press and hold the preset for a couple of seconds, and the edit box will open when you release the button. With the preset open, the operator can input the target pressure and enter a name. Just right here. And then you can change the downforce at any point by pressing on any of these presets. So the system will change the target pressure immediately, and the hydraulic pressure at the cylinders will be adjusted within a few seconds. And the chosen presets highlighted in yellow, whichever it may be. And then once the target pressure has been changed, then that will no longer illuminate. So as you can see here, there's no it's no longer lit up. And then last but not least, you got these guys on the right. So you press on the TruSet seating button at the top right to go back to the main run page. And you press just the setup button in the middle to complete TruSet setup on the machine. And then you can press the diagnostics button at the bottom to open the TruSet diagnostics page. And that's all I had for the new TruSet run pages. So
With that, that's kind of everything we had. If you guys have any other questions, keep them coming in the chat, or we can unmute you at this point. But thank you for coming. Hopefully you guys took away some good tips and tricks or tidbits or a refresher for the spring. But that's kind of all we have. So hopefully you guys have a good spring, and we're looking forward to seeding and hope to hear from you. So thank you.